Let's look at an example of hammer forging in QForm version 8, starting with specifying the initial data all the way through viewing the simulation results and creating an animation file of the results. In this example of 3D hub forging, the technological chain consists of upsetting and final forging, and each operation consists of several blows. Now keep in mind that if the first operation of the forging process is a simple upsetting operation, it is still very important to simulate it so that everything that happens to the billet during the upsetting process is simulated and gets passed along to subsequent forging operations. This will always give you the most accurate results. Now we've already discussed geometry preparation and setting up a simulation in previous videos, so we won't go into too much detail about what each line means. We'll just focus on how to set up a simulation for hammer forging. So let's start here by setting up a technological chain for simulation. Now keep in mind that this example is in metric units, so the program has been set to metric mode. So first, click Create New Operation and start the Data Preparation wizard. In the Process tab, name the operation and select the type of process, General Forming with Thermal Process. Select 3D Problem Type. In the Geometry tab, browse for the SHL geometry files that have already been set up for simulation of the upset operation. In the Workpiece Parameters tab, choose Material and Temperature of the workpiece. In this example, it's 36 Mn6 steel at 1250 degrees Celsius. Now in this tab, specify the tool parameters that include drive type, lubricant, material, and temperature. So we'll use a 2-ton hammer for the upper tool. And our hammer here has already been set up in our database based on the falling mass minus energy loss. And then for the bottom tool, we'll go to Fixed Drives, and we always use plus OZ for a fixed lower tool because it resists in a direction opposite to the motion of the top tool. Select graphite and water from the standard lubrication list, L6 dye material, and a running temperature of 150 degrees for each tool. Select Distance for a stop condition and set 30 millimeters between upper and lower tools so that we will upset the workpiece to a height of 30 millimeters. In the Boundary Condition tab, we don't need to change anything, so just click Forward. The Blows tab is most interesting for hammer forging because this is where we set up how the hammer is operated. Blow energy, the time between blows, and motion can all be set up here in a table. In this example, we'll set up a table to be used in both operations. Our table will be for 8 blows with a rising energy share from 40 to 100% and different values of cooling time between blows. When we first run a hammer simulation, we probably don't know exactly how many blows will be needed, and for sure in this example we won't need all 8 blows just for the upsetting. But since we don't know how many blows are necessary, we should enter more blows than we imagine will be needed, then QForm will solve only as many blows that are needed to fulfill the stop condition. And you can also force the program to solve all blows if you want by setting the corresponding check mark. So we'll set the number of blows to 8 and specify cooling time and energy share as needed. We'll set 3 seconds for workpiece cooling in air before the first blow for the time that the billet is being transported to the hammer from the furnace. And for the rest of the blows, the forging stays in the die, so we'll keep 0 for the cooling and air time. You can import and export the blows table, which can be handy for multi-blow hammer forging. So let's export this table and use it for the final forging operation as well. So click Export Table of Blows and specify the name and directory of the Excel file being saved. On the Simulation Parameters page, you don't need to change anything, so just click OK to close the initial data preparation wizard. So now we've entered the initial data for the upsetting operation, and we need to specify data for the finished forging operation. So select the first upsetting operation and click Create Continuation of Operation. In the process type here, enter the name and check the process type, General Forming with Thermal Process and Problem Type 3D. Select the geometry of the tool for final forging. Since we will use the workpiece results from the upsetting operation, the tool geometry does not need to include a workpiece. We will inherit all of the workpiece data from the first operation in the Workpiece Parameters tab. So we're going to select all the same equipment in the Tool Parameters tab, since this operation is forged in the same hammer with the same parameters. In the Stop Conditions tab, set the distance of 0 millimeters between the tools. And then don't change anything in the Boundary Conditions tab. So now, let's import the table of blows that we set up and exported from the first operation. So click Import Table of Blows and browse for the Excel file that you saved. Don't change anything in the simulation parameter, so just click OK to close the wizard. And now, since all the initial data required for modeling has been entered, select the first upsetting operation to make it active. We can click the Start Simulation button and confirm saving the project. The simulation will now run through all required blows for both operations. When the simulation is finished, the results are shown in the graphics window. You can switch between blows by clicking the buttons on the simulation control panel. We could see that the upsetting operation was produced in 2 blows, so the program had no reason to solve all 8 blows that were in the table. To save an animation of the entire technological process, including both operations, click on the final forging operation to make it active, and click the Create Animation button on the control panel. The animation will run through all blows from the first operation in the chain through to the last blow of the selected operation. Set the path in the file name. Choose if you want to save a sequence of PNG images, Windows Media Video file, or both together. Select the whole chain to save both upsetting and final forging operations, and set the time for the length of the video clip to be saved. Press OK and the animation file will be saved. Thanks for watching.